Okay, for the examples, I only consider the first example and leave the second example for you to read it because it's straightforward. It only needs simple linear algebra. If you understand the first example, then we're done, of course. Consider this linear model, which the expected value of y is given by this column vector, which you can write it as this design with b. So let's consider it as x in a multiply with ob. So the expected value of y is equal to xb. I usually like to write it as x beta, but since we have beta as a parameter, we use notation b here. And also suppose the covariance of y is equal to sigma square identity matrix. It's because we want to look at the expected values. So rather take this covariance matrix in our computation that we can understand better. Now consider the linear function q prime b, and also suppose that q is equal to q1 because we have 4 elements, q2, q3, q4, 4 by 1 column vector, which q prime b is equal to this linear function of parameters. If you remember, we say the rank according to the theorems, the rank of the augmented matrix q prime x is equal to the rank of x. So I'll consider the augmented matrix, this matrix here. Let me get the pointer. The augmented matrix is given by this matrix. We have q elements in the first row and then the x. And if you look at the x matrix, you see the second and third columns are the same. So in this case, we can say, okay, if q2 is equal to q3, then the rank doesn't change. The rank of this matrix doesn't change. So if you want to keep the rank of x, which is equal to 3, we can assume that q2 is equal to q3, or we can say we can get this transformation and write q2 minus q3 instead of q3 here, the column. I call the column here. And in order for the matrix to have rank 3, q2 minus q3 must be equal to 0, which gives q3 equal to q0. Now we can understand the estimable functions. So any q prime b in which q2 is equal to q3 is estimable. For this vector of parameters, for instance, if you look at mu, it is 1 0 0. Sorry, it is again 0 1 0 0 0 b, and you see the second and third elements are the same. So the mu is a estimable function of parameters. Also alpha, you can write alpha as 0 1 0 0, but if you look at it, the second and third elements are not the same, so it's not estimable. Another one, let's look at mu plus gamma. It is if I consider mu plus gamma, it is 1 0 0 1 b, which you can see b is equal, the second and third elements are the same, so it is estimable. However, the gamma itself, look at the gamma itself. Now the gamma itself is also estimable. Sorry, the second, third elements are the same. This is the b vector. However, something like beta minus gamma, if you write it, it is 0 0 1 minus 1b, which you can see the second and third elements are not the same, so it's not estimable. So you see the condition in order that any function of the parameters to be estimable is that the second and third elements are the same. Now let's look at the normal equation and solve the system of equations. Remember the b hat, or better say write the system of normal equations. You can write it as x prime x, b hat x prime y. So we need x prime x and x prime y. X prime x, you can easily get it in this form after some matrix multiplication, and also x prime y, which I use the abbreviation capital Y1, Y2. The second row and the third row are the same, so I use Y2 for the third row and Y3 for the fourth row. So we use this abbreviation. Remember, the rank of x is equal to 3, and we have 4 unknowns, 4 parameters which are unknown, and we want to estimate, and we have 3 equations. It means that I have to set one of the parameters equal to 0 in order to get the solution. In order to see it better, you see from the normal equations, if I bring it here, from the normal equation, if I multiply the first row, then I can easily get 8 mu hat equal to the first row, which is equal to y1, which you can easily get mu hat equal to 1/8 y1. Okay, and also you can simply get 8 gamma hat equal to y capital Y3, which we then get gamma hat equal to 1/8 y3. But we only have one equation left to solve for alpha hat and beta hat. So we have to set one of the parameters equal to 0. Remember, both alpha hat and beta hat are not estimable. You see here, if I use the pointer again, you see here alpha is not estimable, and if you write it for beta, then the first element is 0, the second element is 0, the third element is 1, the other one is 0. So you see the second, third elements are not the same. So beta is not also estimable. So we have 2 parameters, alpha and beta, which are not estimable, and we have to set one of them equal to 0. So you can either say alpha hat equal to 0 or beta hat equal to 0. In this node, we have beta hat equal to 0. Then you can simply get alpha hat as 1/8 y2. So the best estimator of q prime b is indeed q prime b hat, which is equal to this equation here. Furthermore, if you write the SSR, you can simply get based on the above formulas. We can even find the SSE, and we can find the MSE based on SSE. Remember, it's 1 divided by the rank times SSE. So you can simply get the total sum of a square based on the sum of a square of regression plus the sum of a square of error. The second example is pretty simple, similar, and you can follow easily. I just stopped the record. Thank you.